Good morning students. Today let us study the new topic in physics, that is chapter 12, electricity. We have four major topics in this chapter that we have to go through. That is the first one, electric current. The second topic, electric potential. If we understand electric current and electric potential, next we can study about Ohm's law and numerical based on it, which is very important. The fourth topic that we are going to study, that is heating effect of electric current. So these are the four major topics which we are going to study under the chapter electricity. Okay, you all know that electricity plays a major role in modern society. It is one convenient form of energy used in various places like homes, schools, hospitals, industries, etc. So in this chapter, let us study in detail about it. Yes, first of all, we have to understand what constitutes electricity and how does it flow in an electric circuit. What factors that are controlling the current in an electric circuit. So this all answer we are going to get by studying this chapter. So let us move on to the topic now, that is electric current. Yes, what is electric current? I think you have already studied in 8th standard about the chemical effect of electric current. So you have gone through the definition of electric current. I think you have the answer in your mind. Yes, the answer is it is the rate of flow of charges. So electric current is nothing but the rate of flow of charge or flow of charge with respect to time. So now, which are the charges? How the charges are moving? We are going to study. So to understand the definition, to know about the charge, so let us study now what is charge. Okay, what is the charge? Yes, you all know it is the fundamental property of matter where it is experiencing a force. Again, this you have studied in 8th standard that charges are of two types, that is positive charge and a negative charge. Here, positive charge, that is the proton. Proton is having a positive charge. And if you consider the electron which are present in the atom, so which are revolving around the nucleus of an atom, there the electrons are present where electrons are having negative charge. So since charge of an electron is very small, so the charge of an electron, yes, what it is? The charge is minus 1.6 into 10 raised to minus 19 coulomb. Okay, so here the charge is having a practical unit here, that is coulomb. So 1 coulomb is equal to how much? 6.25 into 10 raised to 18 electrons. This value also you all know that in 8th standard chemical effect of electric current, in that chapter you have studied about it. Value of the electron is having the charge, that is 1.6 into 10 raised to minus 19 coulomb, and 1 coulomb is equal to 6.25 into 10 raised to 18 electron. Okay, so this thing you'll have to remember. So these are the two values which you have to remember. Now let us see in this picture that force between charges. So what kind of forces are present? So you can see here the first where is positive charge and a negative charge. So in between positive charge and a negative charge, that is the force of attraction. Okay, so forces between two unlike charges, that is there is a attractive force. In the same way, the charges, like charges, are in between the like charges, there is a force of repulsion. Okay, so you can see here that in between positive charge and a positive charge, there is a repulsion. In the same way, in between negative charge and a negative charge, there is a force of repulsion. Okay. So, yes, now you have understood about charge. So, let us move on to the next topic, that is, yes, what is the basic difference between conductors and insulator? Yes, what is the difference between conductor and insulator? You can give the definition easily. Yeah. So, you have studied conductors are the substance which allow current to pass through them. You can give examples as iron, silver, aluminum, etc. And insulators are the substance which do not conduct electric current. For example, plastic, glass, rubber, etc. Yes, this response is okay up to 8th standard. Okay, so till 8th standard you will have studied this definition. But coming to 9th standard, you will have studied about atomic model and structure of an atom. Yeah. So this knowledge about atomic model and structure of an atom should be included now to define the conductor and insulator. So what concept it is? That is the concept of free electrons. So you have to think, why does the conductor conduct electric current whereas insulator cannot? Yeah. So conductors can conduct. Why not insulator? That is because the conductor consists of free electron. It contains free electrons. So what are free electrons? That we have to study. Okay. So what are free electrons? The concept of free electrons. So the matter is made up of atoms, and each atom has a positively charged nucleus at the center with negative charge electron revolving around it. Yes, you can see here in the picture where here the positive charge, that is the nucleus, and around the nucleus there is the orbit. So in the orbit the electrons will be revolving. So in the picture you can see the outermost orbit only. Okay. So the electron which is in the outermost orbit. So here what happens? The electrons which are negatively charged is bounded by a positively charged nucleus. Okay. So there is a force of attraction due to which the electrons are moving in its orbit. So if we provide energy, so you can see here the energy is provided. So when the energy is provided on the outermost electron, so what happens? It is going to come out of an atom. So it will not remain bound to the nucleus and just come out of an atom. So when it comes out of an atom, what happens? It is free to move in a material. So here we call this type of electron as free electron because it is not bounded by the particular nucleus and it is free to move within the material. Okay. So it is free to move within the material. So now, whether all the materials are having the same free electrons? No. For some materials, energy required to free an electron is less. Okay, it can be acquired by the surrounding at room temperature. So, for some of the materials, energy required is less to free an electron. There are some materials where it requires more energy, external energy. So these free electrons contribute to the electric current. So in a material which electrons are made free, these free electrons contribute to the electric current. Okay. Other electrons which will remain bounded to the nucleus, they are not going to involve in the flow of current. They are at the stationary phase. Okay. So the electrons which are bounded to the nucleus do not contribute electric current, but when the external energy is applied to the material, the electrons which become free, that electrons will conduct electric current. Okay. So now we can define conductors and insulator, right? So now we can define conductors based on the concept of free electrons as The materials, so you can see this definition here. The materials which can produce free electrons at room temperature are known as conductors. That is, because of less energy required to free an electron. So the materials which can produce free electron at room temperature are known as conductor, where it requires only less energy to free an electron. But the materials which cannot produce free electron at room temperature are known as insulator. That means it requires large amount of energy to free an electron. Okay. So now we all understood the concept of conductors and insulator based on the free electron concept. Okay. Now you all have understood that to conduct electric current in a wire of any material, then that material should be a good conductor. So when we call it as a good conductor, that means that material should have a free electron. Okay, you have to remember this. When the material becomes a good conductor, when it is having a free electron, or it can be the electron which is in the outermost orbit can be made free easily with less energy. Okay, so this we have to remember. Let us move on to the next concept. Now you have understood about the charges. So which are the charges? That is nothing but the free electrons. Okay, the charges are the electrons. The flow of charge we call, right? The flow of charge, that is the flow of electrons. Okay, charge is nothing but the electrons here. So we can define electric current now. Yes, what is the definition of electric current then? Flow of free electrons through a conductor. So in a conductor, the electrons flow, the free electrons flow in a given direction is known as electric current. So with respect to time, okay, you have to remember that. The flow of free electrons through a conductor in a given direction is known as electric current. So electric current is measured as, so here you can see the formula where I is equal to Q divided by T. I equal to Q by T, where I is the electric current and Q is the charge and T is the time. So electric current is equal to charge divided by time. That Q is the charge, which the unit of charge is coulomb, okay, which is denoted by the symbol capital C, and time T, which is in seconds. So here electric current is having a SI unit. The unit of the electric current becomes coulomb per second, because Q divided by T, that is coulomb per second. The SI unit of electric current is coulomb per second, or it is also called as coulomb per second is also called as ampere. Okay, so coulomb per second is also called as ampere. What is coulomb per second? It is the SI unit of electric current. Coulomb per second is also called as ampere. So SI unit of current is coulomb per second or ampere. Okay, so this is given to honor the French scientist Andre Ampere. Okay, A. Now, one thing you have to remember. You have to remember both the units. Because there may be some question like this. Identify the quantity represented by the SI unit coulomb per second. I'll repeat. Identify the quantity represented by the SI unit coulomb per second. So the answer is electric current. So then I have not given ampere, SI unit ampere. They have given the SI unit coulomb per second. So if you remember coulomb per second and also ampere, then it is good. Okay. So the answer for this question, identify the quantity represented by the SI unit coulomb per second is electric current. So the answer is electric current. Okay, let us move on to the next topic. Okay, let us study the flow of charge. Let us understand the flow of charge with the help of an activity. Okay, so you can see in this slide. So in order to understand the flow of charge to a conductor, now let us consider a hollow pipe. You can see a hollow pipe here which contains 7 balls. Yes, so 1 to 7. You can see there. So if you try to push one more ball into this hollow pipe, okay, a ball would come out from the other end of a pipe because there is no space for the other ball. It means that at any given time there cannot be more than 7 balls in the pipe. Yes, at any given time there cannot be more than 7 balls because there is no space for an extra ball. Yes, you can see in this pipe there is no space here. So if one ball is entered from this side, what happens? It is going to exit. Yeah. So the same concept is followed in a conductor. Same way the flow of charges takes place in the conductor. So now mechanism of flow of charge. So going through the same logic which you understood in the last activity, here you can see the conductors may have billions or trillions of free electrons, but there is no space for an additional electron. So how much of electron is present in the conductor? It remains. No extra electron can be added. Okay, means that when we push an additional electron into the conductor from one end, an electron will come out from the other end. This happens instantly. Okay, it means there is no time gap between the pushing of an electron from one end and jumping out of an electron from the other end. Both are, if you enter it at the same time, from the other end, the electrons are going to come down. Okay, either the length of the conductor is 1 meter or 1 kilometer, whatever it is. So it is not depending on the length. Okay, so how much of electron is present in a conductor? It remains constant. Okay, so you have to remember that no extra electrons are constituting the electric current here. The electron which is present in the conductor, only there the flow of charge takes place. Okay. Is there any charge on a conductor when current is passing through it? Well, I have this question. Some of them may have the question in the mind. Whether the conductor is having any charge when the current is passing through that conductor? No. There is a general misconception among the students that during the flow of current through the conductor, additional charges enters the conductor and because of it, it will no longer remain neutral. As we have understood the activity, there is no space for additional electron in the conductor. Remember that. There is no space for an additional electron in the conductor. Therefore, the number of electrons in the conductor remain constant. Have to remember this. The number of electrons in the conductor remain constant even during the passage of current through it. Not only before passage of electric current, after the passage of electric current also, the conductor, when the current is passing through the conductor, the electron remains constant. Okay, so there is no change in the conductor, no charge on the conductor ever though current is passing through it. So there will be no charge on a conductor. It will not become a positive charge or a the conductor is not going to take any charge that is positive or a negative. Okay, whatever the free electrons which are present in the conductor, it remains constant there. So there is no, okay, you understood now? So it means that if there is 100 electrons in the conductor, after the current is passed through it also, the 100 electrons only will remain. So there is no change in electrons. Yes, now let us move on to the next topic, that is 1 ampere. Yes, what is 1 ampere? So now the definition for the SI unit of current. Yes, what is the SI unit of current? The SI unit of electric current is coulomb per second, or it is ampere. Okay. So in order to measure the flow of electrons through a conductor, now let us consider pushing 10 electrons into the conductor in 1 second. So when 10 electrons are pushed in 1 second, so 10 electrons will come out from the other end, right? During the same time period, that is during the 1 second. So the flow of electron becomes, what happens? 10 electrons per second. The flow of electrons is 10 electrons per second. In the same way, if we push 1 million electron into the conductor in 1 second, the flow of current becomes 1 million electrons per second. So by the same logic here, let us understand what is 1 ampere. Yes. When 1 coulomb of charge, 1 coulomb is equal to how much? I told you that is 6.25 into 10 raised to 18 electrons. Okay, when 1 coulomb of charge passes through a conductor in 1 second, the flow of charge is said to be 1 ampere. Yes, you can easily remember this. I will tell you, you can easily remember this by writing the formula. So that is I is equal to Q by C. Yeah, so you all know the unit of current is ampere. So the unit of charge is coulomb and the unit of time is second. Okay, so add 1 here. Okay, now you can define easily 1 ampere. Yes, what is 1 ampere? When 1 coulomb of charge passes through a conductor in 1 second, is called as 1 ampere. Okay, so what is 1 ampere? When 1 coulomb of charge passes through a conductor in 1 second, then we say that the flow of charge in a conductor is said to be 1 ampere. So you have to remember this definition, okay, which is important for 1 mark. The question may come. The question may be what is 1 ampere, or define the SI unit of current. Define the SI unit. What is the SI unit of current? If they ask, you have to write only the SI unit of current is ampere or coulomb per second. If they ask you to define, then you have to define the SI unit of current, that is ampere. You have to define 1 ampere. Okay, so you can see the definition here. When 1 coulomb of charge passes through a conductor in 1 second, the flow of charge is said to be 1 ampere. This is the definition. Okay, so you have understood about it, right? So easy method, you have to remember the formula and you have to write down the units according to that and add 1 before that, and you can easily define. No need of by hatting. Okay, now how do the current is measured? How the current is measured? Yes, there should be an instrument to measure current. Yeah, so that instrument is nothing but the ammeter. So what is an ammeter? So it is a device used to measure the current in the electric circuit. Okay. Yes, I remember I had shown you this device in 8th standard while learning the concept of chemical effect of electric current. Yeah, ammeter device was shown for you all. Yes, you can see here ammeter in the picture. So this device is used to measure the electric current. So while drawing the circuit diagram, we cannot draw this device. In place of this, we are noting the symbol. Okay. So what is the symbol? That is capital A. So this symbol given for ammeter. So ammeter symbol, that is where this is the symbol of ammeter. Okay, you have to remember. So you can see the circuit diagram here, where ammeter is connected in the circuit, where it is the battery, there is the fuse, here is the battery, okay, resistor, voltmeter, okay, bulb, LED bulb, and a ammeter, where it is a ground connection. So now you can see here the positive terminal. Here you can see the negative and positive terminal will be there for the ammeter. Okay, here the positive terminal of the ammeter is connected to the positive side of a battery. This is the positive side of a battery. This is the negative side of a battery. Here you can see positive, negative. So here this side is the negative terminal. Negative terminal is connected to the negative terminal of the battery, and positive terminal of the ammeter is connected to positive terminal of the battery. Okay, so you have to remember this. And also one thing you have to remember, ammeter is having very low internal resistance. Okay, about the resistance you are going to study in the next class. And you have to remember, always the ammeter is connected in series. Series connection means end-to-end connection. One end of positive end is connected to the one end of the resistor, and the other end of ammeter is connected to the other end of the resistor. That means end-to-end connection is given, then we call it as series connection. Okay, so ammeter is always connected in series with the resistor, and it is having low internal resistance. Positive terminal of ammeter is connected to the positive side of the circuit, and negative terminal is connected to the negative terminal of the battery. Okay, so you have to remember this part always. Okay, now let us move on to the last topic of today's class, that is, what is the direction of conventional current? Yes, you have studied the flow of electron. What is electric current? The flow of electron, flow of free electron. Here we have to, in a particular direction it was told, right? So now what is the direction of conventional current? You have to know. Yes, in the last picture you have seen the current flows from, here you can see the positive terminal. Okay, so the positive terminal, yeah, positive terminal of the battery, and here the negative terminal of the battery. The electrons flow from negative terminal to the positive terminal. So the flow of electron is from negative terminal to the positive terminal. But the electric current flows opposite to the direction of flow of electron. That is by convention that always the flow of electron is opposite to the flow of free electron. If the free electrons are moving in this way, then the conventional current is in the conventional current flows in the opposite way. Since the free electrons are not bound to any particular nucleus, they can move freely within the conductor. But by convention, the flow of positive charge is considered to be the opposite, the direction of the current through the conductor. The direction of conventional current is opposite to the flow of free electron. So it is opposite to the flow of free electron. You can see this is the direction of electric current. This is the direction of free electrons. Okay. Also, you have to remember this concept also. Yeah? Yes. In today's class, we have studied about, first and foremost, you have to remember what is electric current. Once again, I'll repeat. What is electric current? It is the flow of free electrons with respect to time in a given direction is called as electric current. So, definition of electric current will come for 1 mark. It is important. Next, the SI unit of electric current. The SI unit of electric current is ampere or coulomb per second. And the third question, formula. You have to remember what is the formula for electric current. That is I is equal to Q divided by T, where Q is the charge, that is in coulombs, T is the time in seconds. So electric current I is equal to charge Q divided by time T. Next, the fourth question will be, define the SI unit of electric current, that is or define 1 ampere. Directly they will give the unit. Define 1 ampere. Yes, what will be the definition? The current in a conductor is said to be 1 ampere if 1 coulomb of charge flows through the conductor in 1 second. If 1 coulomb of charge is flowing in 1 second, then the current is said to be 1 ampere. Okay, this you have to remember. And the direction of the conventional current, that is opposite to the direction of flow of free electrons. Current is flowing opposite to the direction of free electrons. So this 4 to 5 points you have to remember. Okay. So in the next class, let us study about electric potential. The next major topic, that is electric potential. Let us study in the next class. Thank you.